This is going to be Chapter 8, Graphing Periodic Functions, and we're going to start off by graphing the sine and cosine functions. So the first thing that we really have to do is try to figure out how exactly sine and cosine look when you graph them, and actually graphing it is going to be very important when we when you guys go to pre-calculus and even in calculus. So knowing the sine and the cosine curves are going to be very, very important. So the first thing to kind of know is let's start off by graphing the sine function. Now we know from the unit circle, so if we have our unit circle, we have many different points that we can choose from. We have various different angles. Now we want to be careful with what angles we want to choose. So in particular, the angles that we're going to choose are the quadrantal angles, because you'll see that when you have 0, pi over 2, pi, 3 pi over 2, and 2 pi, you see that when you go into these quadrantal angles, you'll actually have nice numbers. So, for example, this guy is just going to be 1, 0. The point here at pi over 2 is going to be 0, 1, then negative 1, 0, and then 0, negative 1. So these are much nicer numbers. So if I were to choose the angle pi over 4, you can see that the numbers are going to be a little harder to draw. So, but we do need to kind of keep it in the back of our minds that these angles are, for a particular angle, there are some points. So it's not going to be exactly linear. There's going to be some sort of curvature there. So we'll start off with the sine function. So we'll start off with 0, because 0 is going to be the easiest one to do. So the way that I'm going to do it is I'm going to do 0, then I'm going to go to pi over 2, then I'm going to go to pi, then I'm going to go to 3 pi over 2, and then I'm going to go to 2 pi. Okay, so we're going to start off there. Now, remember that the sine function is always going to be the y-coordinate in the unit circle. So basically, when you are at 0 radians, your y value is going to be 0. So basically, the sine curve is going to start at the origin. Then when we move to pi over 2, so here we're right here at 90 degrees, your y value is now going to be 1. So now this is going to go up to 1. Then you go to pi radians. So at pi radians, you're going to go back to 0. And then when we go to 3 pi over 2, it's going to go down to negative 1. So we're going to write negative 1 right here. And then finally, when we go to 2 pi, you're going to go complete one full cycle. So basically, this can keep going because I can keep going back to the coterminal angle of pi over 2. And notice that what's going to happen, so the coterminal angle of pi over 2 be 5 pi over 2. So if I continue, you can see that this whole cycle is going to continue on. So if I were to choose more points, and continue this, you're going to just keep repeating itself. And same thing in the negative side. Okay, so for this one, it's going to go down to negative 1, okay, because that negative pi over 2 is going to be right here. So what you end up getting is not something that's linear. So it's not going to be a straight line in every single direction, because you can see that for me to go between 0 radians all the way to pi over 2 radians, you kind of have this curve. Okay, so basically you kind of have or embedding this particular curve all throughout. So the sine curve looks something like this. Okay, and it continues on. So so it kind of looks like a wave. Okay. And notice that it keeps repeating itself after 2 pi radians. So if we were to take a little slice of it, so if we take a slice from here to 2 pi, you can see that this pattern keeps repeating itself. Okay, so you kind of have this wave. So the one that we're really going to be worried about is, let's just look at from 0 to 2 pi. What exactly is it going? This is the shape that you're kind of having. Okay, so remember the shape. So the sine curve starts at 0 and then it makes its little wave. Okay, So that's the sine curve. So now what we want to look at is we're going to look at the cosine curve. Okay, so let's take a look at the cosine curve, and we're going to do the same exact thing. So we're going to still do the quadrantal angles, 0, pi over 2, pi, 3 pi over 2, and then 2 pi. We're going to have 1, we're going to have -1. So now in this case, and you can keep going if you want to, if you really want. Now in this case, we're starting off with cosine. Cosine in this case is going to be the x value. So at 0 radians, you can see that the cosine is going to be 1. So that one's going to start at 1, not at 0. Then when we go to pi over 2 radians, okay, you're going to go down to 0. Then when you go to pi radians, so now we're right here, you're going to go at -1. Okay. At 3 pi over 2, we're going to be at 0. And then at 2 pi, it's going to be at 1. So now this graph looks a little different. Okay. So it kind of looks like this. Okay, let me draw it a little better. Okay, so this is what this graph looks like. Okay, so you can kind of see that if I were to shift this the sine over 2 pi over 2 towards the left, you kind of get the cosine curve. So this is going to continue on. So if I wanted to make more points, right, so also a -pi over 2. If I wanted to kind of keep getting more points, this is basically what the graph is going to look like. Okay, so it keeps repeating itself. So what is the pattern that it repeats itself? So let me go ahead and go back to my yellow. So this is basically the pattern that we're going to look at from 0 to 2 pi. Okay, so this guy kind of looks like a V. This kind of looks like an N. Okay, so so you have to be able to memorize these shapes, know where exactly the cosine starts, know exactly where the sine starts. Okay, so the sine always starts at 0, whereas the cosine is always going to start at 1. Okay, and a couple things that you can see. So I wrote down a couple characteristics. So for example, the cosine curve, or let me just look at the cosine curve. So you can kind of see that it's kind of symmetrical, because if you look at the middle of the y-axis, you can kind of see that this particular shape. So if I look at -pi over 2 and pi over 2, you kind of have a mirror image. Okay, so this guy right here mirrors this guy. Okay, so they're a mirror image. So basically the cosine function is symmetric about the y-axis. So here we're going to say a function is even if it satisfies the equation f of, when we plug in -x, I get f of x. So in other words, it is symmetric about the y-axis. Okay, so basically you have this mirror image here. Okay, which means that cosine here is an even function. So it's even. So that later on we'll figure out that when I plug in a negative value into the cosine, it actually is the same thing as just plugging in a positive value. You can kind of see this here, because you can see that if I were to plug in a positive value here, plugging in the exact mirror image of the negative value is still going to give me the same y value. Okay, so that's what it means to be even. A function is odd if when I plug in the negative, you get the negative of the y value. So this is what we call symmetric about the origin. So the sine function actually is an odd function. So one way to kind of see this is that if I were to plug in pi over 2, okay, then you're going to get 1. If I were to put -pi over 2, then you're going to get the negative of whatever the other one was, which in this case is -1. So whenever you have this opposite pattern, we call it odd. So you can see that this guy right here, this little part, actually is kind of symmetrical to this little part right over here. So it's kind of like across from each other. Okay, so we call this odd function. So really remember that the cosine is going to be an even function. The sine function is going to be an odd function. A couple more characteristics about the functions. So These are called periodic functions. So they have a period of 2 pi. So a period is basically one full cycle. Okay, so that means that these periodic functions are going to complete one full cycle every 2 pi radians. And you saw that here. So this guy tends to repeat itself. So from 0 to 2 pi, you have this pattern. And then after 2 pi, is going to repeat the pattern again. Same thing with the cosine function. From 0 to 2 pi, you tend to get this pattern. And then after 2 pi radians, you repeat the same pattern. Okay, so that's what it means to be periodic. The domain in this case, which is all possible x values, so it can be anything because I can literally plug in any x value that I want, any angle, and I will always get a y value. Okay, so none of these are undefined. And the range, which is all possible y values, is between -1 and 1. So you can see that when you look at these functions, they are not exceeding, well, if I were to draw this right, they are not exceeding -1, or they're not less than -1 or greater than 1. Okay, so they are just squeezed between these two numbers. Okay, and will always be the case unless there's a number in the front. Okay, so here are some characteristics. I also said sine is symmetric about the origin because it's an odd function. The cosine is symmetric about the y-axis because it is an even function. Okay, so here are a couple characteristics. Make sure that you really understand how the sine function looks and how the cosine function looks. And then what we're going to do in the next video is we're going to do this, which is going to be graphing them using various different things.